So, hello, welcome to the second day of the Earth EarthMoonMars to Isa Lab workshop. Now we had the day on Friday, and today we are going to talk about EarthMoonMars and Chile's EarthMoonMars campaign. So I'll give a synthesis of what this workshop is and how we are transiting from this EarthMoonMars program we started 10 years ago towards Isa Lab, Earth Spaceship Academy Laboratory for Astronautics and Business. And here I've put a number of names of collaborators in the last years in our project. So we have a working group looking at Moon and Mars mission science and technology with space agencies, academia, and industry, looking at exchange of information between the different Moon and Mars missions. We are also having a strategy group looking how we go towards the future mission and Moon-Mars settlements with the International Lunar Exploration Working Group and also other stakeholders. And we had the Young Lunar Explorers group that started 20 years ago with the Lunar Explorers Societies and also a specific program for young professionals for training, student payload, curriculum, outreach, and grants. So we started this millennium with lunar mission, Smart One, and you can see here the teams of engineers and operation engineers as well as scientists. And we developed a special technology for that. And this was also a way to develop a mission in a shorter time scale, showing that we can do it in a So we obtained results about the moon, but during the cruise, we also observed the Earth and validated the technology of the mission. So 20 years ago, we formed the International Lunar Exploration Working Group, actually 25 years ago, which has proposed a roadmap towards the moon village with 4 phases, a phase with a precursor, robotic mission orbit, a surface robotic village, and then a deployment towards the international outpost, and then a moon village, a permanent and sustainable outpost with humans and robots. 20 years ago, a group of young professionals that were gathered at the occasion of the international conference at ESTEC asked us some recommendation to create a Lunar Explorers Society, to have a special communication channel for young explorers, and also student lunar project, as well as opportunities for young professionals, and they also endorsed our roadmap to the moon village. So we try to satisfy some of these requests. So we have a working group on the data, so data on Earth from space, and you have heard some result from this ongoing research, data about astrophysics and the study of exoplanets and stellar variability. We are also analyzing space science data, and we have a specific group looking at Moon-Mars data and science. So we have heard about Earth observation. We also observe the Earth from the moon, giving us this global perspective and awareness of the Earth. So on ESA, we have a program of Earth Explorers, and we have also a program together with the European Union on monitoring the Earth with the Copernicus. On analyzing data, we have a set of activities looking at data from the previous missions and inspire the scientists, but also everybody in the community. So we were able to perform the first map of the globe, the poles of the moon, where we have identified some areas where in the future we will be able to put robotic landers as well as human bases. So we have specific activities trying to develop and demonstrate some instruments, and also we want to coordinate various activities between different actors to set up this robotic village we have mentioned, and we have activities related to human bases. So for preparing the robotic village, we started a program, EarthMoonMars, with a lander, ExoGeo Lab, that we built, and we tested with various instruments and teleoperation with young professionals. We tested it in volcanic analog environment, and we also conducted in the last 11 years some campaign in extreme Moon-Mars analog, where we conducted laboratory and field research, demonstration of instrument, technology of habitat and human aspect, and also opportunity for training young professionals. We even had a spacesuit to perform extravehicular activities. So every year we organize 2 or 3 EarthMoonMars workshops at ESTEC in the last 10 years. This year we performed 2 virtual workshops like the one which we are having this time. We have also some hands-on training inside a mini moon habitat that we have built, where we can lock down some young professionals for some time so that they can perform some experiment and look at protocol of communication and survival on the moon. We also developed an exobiology laboratory as a test for what could be deployed on the surface of the moon. So in 2017, we conducted a campaign in the Lunares base in Poland, where we had simulations. And also in 2018, we started a program on EarthMoonMars Iceland. And you will hear more today about the preparation for the next EarthMoonMars Iceland Chill Ice campaign, which is led by younger professionals. We hear Mark, Sabrina, and Charlotte will present you this campaign. So in 2019, in the frame of the ESA Lab, the Federation of Various Universities, we participated to the Igluna project, so where there was a moon base that was built in a glacier, and the various ILWIG and Free University Amsterdam and EarthMoonMars team provided some contribution to this project with investigation, even deploying an exhibition of the moon gallery at the place. And so we had an habitat, we had advanced technologies of robots or growing plants, and even we brought to the summit of the glacier our lander as well as our moon. So more recently, as we have discussed, we have used ICES base together with the International Moon Base Alliance to perform a number of campaigns now, which are called EarthMoonMars IMA ICES EMIS campaign. So EMIS 0 was in 2018, where with the enclosures that you have met, the owner of this facility, we performed some technology tests and some first sorties from this moon base that you can see here. Subsequent campaign have explored this volcanic area around the ICES facilities. We had some geologists from Free University Amsterdam. You have heard Anne-Lotte. They have explored lava tubes, and also they have explored the new ways of living in an isolated environment, seen in good comfort. We even had the first all-women crew on the surface of the moon, and that was in this ICES base. We hope we will have also the first gallery of art on the moon, or the first artists, women on the moon. We will hear more about that. So there are a number of challenges for implementing this moon village to get there, to survive, to operate, communicate, move with humans and robots, use the resources, and also address the needs from all users and to the benefit of humankind. So that's our vision for sustainable presence on the moon village. And so we are working with this EarthMoonMars group and also various projects that we have to go in this direction. So in terms of COVID, we have been able to continue some activities. In particular, we organize workshops, outreach, and art events in various places: Amsterdam, Aveiro, Leiden, where there is at present an exhibition, Closed Cosmos, that is shown to the public. And we have also organized events in Toulouse, Vienna, and in Poland. And we were also giving virtual talk at symposia. So we are resilient to the situation. And indeed, as you have seen from the result from yesterday's campaign, we organized EMPOL EarthMoonMars Poland campaign in the last 2 weeks of October, where we had 2 crew spending 1 week inside the moon base in isolation. So we have shown some of the experiments. They have performed some artificial intelligence, some biocontamination experiment, bioreactor, and we had these 2 rotation of crew, EMPOL 1 and EMPOL 2, that were also conducting very interesting scientific experiments. You have heard about 3D printing, aquaponics, space weather, drinking alkaline water. And also there are special training that was conducted at the Mission Control Center They were helping the moon base at distance, but also they even deployed some EarthMoonMars artifact and our iconic moon gallery from the Mission Control Center in Poland. So important crew as well as well operated, and you have heard some of the results that you have. In particular, we are very concerned about human factors, the human aspect, communication, leadership, workload management, awareness, and how to take a decision in interdisciplinary international teams. Some experiments that were conducted, aquaponics, microbiology. And so indeed, that's how with our MoonMars group that now we want to expand even to include other topics like earth science or even astronomy, and we call it ESA Lab, so Earth Spaceship Academy for Laboratory of Astronautics and Business. This is the topic that we want to address from a technical point of view and human factor studies, but also we believe that we have to enlarge some of the remit of what we have been before, go beyond science, technology, training, and outreach to also include inspiration and society aspect and diversity and art. So for this reason, we have included this new astronaut training academy we have described, and a special pillar of activity, which is Earth, Moon, Mars, Space, and Society, where we work with, in collaboration with, for instance, the Itacus Committee and various humanities universities. And we want also to increase the business aspect, the services to society, and to get also some of the resources to conduct our project. And finally, as a transition to our next session, we have started a platform, EarthMoonMars, 10 years ago, where we organize events, conference, workshop, exhibitions, and this involved various also studies that we have performed, for instance, on overview effect, on bringing an Alexandria library on the moon, or studying planet Earth, or preserving life on Earth on the Noah's Ark, but also we had performances of music, and we will hear also about First Artists on the Moon, a project that we are conducting now, and we have also consolidated a project that is a pilot project that is called the Moon Gallery, and even established this year the Moon Gallery Foundation. So this was my introduction and also overview of this overall workshop. And now I have been joined here by the curator of the Moon Gallery that will be now in charge of leading the next session. So we have with us. So we are recording this event, and so it's my pleasure to introduce the curator of the Moon Gallery. So we have Lisa Glukova and Anna Sinikova, and we have a number also of participants to this Moon Gallery. So now the floor is yours, Anna, Lisa. And we have also the participant of the session, EarthMoonMars Iceland Shield Ice, which have joined us, and as well some of the participants of yesterday's session. So welcome back.
Hello, thank you for the introduction.
Hello, I'm Yelizaveta, and together with Anna today we're gonna tell you a little bit about the Moon Gallery in general, about how the project was established and what kind of updates happened during the last year. So the beginning of the project is started from the question of how to engage in a space socio-cultural community. With this project, we would like to give a different perspective on the space exploration. Space is known as this very challenging milieu where only scientists and engineers get to operate. But with the EarthMoonMars platform, which we run together with Bernard Foyn, Mary Cowper, and many other collaborators who join us for some particular project, we want to offer a perspective where the most exciting collaboration between art, space, science, and engineering can happen and drive this exploration.
Together with the EarthMoonMars team, we support various initiatives connecting art, the moon, Mars, and beyond. We organize meetings, workshops, art science space classes and projects at various universities, sessions at the international conferences, art exhibitions, and even visual performances.
So the framework for the activities of the Moon Gallery, it kind of originates from the concept of the Moon Village. The concept of the Moon Village is the assembly of all efforts from the private, governmental, cultural, and other sectors aiming to establish a sustainable human space exploration.
3 years ago, we started working on the Moon Gallery project, within the framework of EarthMoonMars and Moon Village. The Moon Gallery, we believe it could serve as a focal point for ideas and visions of Moon Village community, instigating intrigue, imagination, and inspiration for space exploration. At the future Moon Village, Moon Gallery will be the first permanent museum on the moon. The idea might seem far-fetched, but you will have to agree that it is absolutely feasible and not too far in the future that we will have this first permanent museum established on the moon.
So Moon Gallery project is managed by the Moon Gallery Foundation team. Here you can see the core or official team, and of course we are joined by many others who support us. With the Moon Gallery Foundation team, we are wondering what would be the new values, ideas, concepts, and aesthetics that will be established beyond the Earth planet. How, for example, dance or sculpture would look like in zero gravity or 1/6 gravity conditions. How would our perception of beauty will change due to the change of our bodies in the different environment?
Yes, which new art forms will sprout in such a different context that space can offer us? It has been almost 50 years since art was last placed on the moon, so it's time to go back. And it is, of course, challenging to select a particular artwork that would serve as a seed of moon culture, actually shaping future culture. Luckily, we don't need to select.
We create open calls where we invite international community or artists, engineers, scientists, and society at large from all over the world to join with their ideas of what they would like to send to the moon. We ask our participants to think big but small. Each idea has to fit within just 1 cubic centimeter.
So the format of the Moon Gallery is inspired by BioPen, which you can see here on the screen. It's a research project to investigate the effects of the space environment on biological material. And this, as you can see, it was a kind of tray with a grid where you see different materials exposed to solar and cosmic radiation, the space vacuum, and weightlessness. And in the Moon Gallery, we also have a similar approach. It is a grid with 100 cubic centimeter cells, but instead of showing biomaterial, we have each cube is occupied by a beautiful artwork. So maybe, yes, here you can see how it would be mounted on the exterior paneling of the lunar lander.
So the flight model of the Moon Gallery is very miniature and lightweight due to the high cost of the space travel. So you can see it's just 10 by 10 cubic centimeters, which will host 100 ideas submitted by artists from all over the world. It would be mounted on the exterior paneling of the lunar lander and will travel to the moon along with the scientific payloads. We organize regularly exhibitions here on Earth, traveling around the globe, where we show a collection of the Moon Gallery, which we have so far, and scout the new artists for the gallery. Moon Gallery also exhibits online, where you can explore the collection which we have so far. So here you can see the main type of events which we engage in. So of course that's exhibitions and collaborations. That's when we find a partner or space which want to show Moon Gallery, and we develop a special project based on who is our partner is. We really like being inspired by the space and stargazing. So we organize some astronomy events together with our collaborators from the EarthMoonMars and others. We really enjoy making workshops and educational projects. We sometimes have lectures or programs in various universities. And also we find it most effective when the ideas for the Moon Gallery project originate from the workshop, because we find it the most effective way to engage and involve everyone in this interdisciplinary collaboration. And of course, symposiums and conferences where we can present the milestones and results of what we have done, and also learn more about the scientific part of the space exploration. So here there are a few examples of the exhibitions that we've done throughout the time. Here you can see, well, it was the second event, but to be a first exhibition which Moon Gallery made. It was in 2018-2019 in the Space Expo Museum, not far away from the ESA Aztec. And there you can see the gallery, like first prototype of the gallery with just a few artworks. We've been on the Milan Design Week in 2019, where we got quite a lot of involved quite a lot of from the visitors of the gallery, who later became also the members of our community. This is one of the local events which took part in The Hague during the quarter. That's an annual art event. We also collaborated with the Igluna ESA Lab, which was a very exciting collaboration, because there, of course, we had our regular Earthling exhibition in Zermatt downtown in Vernissage, but also, we could have a sort of demonstrator of how the gallery would look and function on the top of the Kleine Matterhorn mountain in the glacier. We also been to Design Blog to Prague in the end of 2019. And
the gallery is currently on show at the Leiden University Observatory, the oldest still operating observatory in the world. It was founded in 1633. This historical monument still plays an educational role for the Leiden University and for the city of Leiden. Observatory is designed for research and also kind of expanding of human perception. We believe that the Moon Gallery artists are a little bit like an observatory. They aim to raise perception by asking fundamental questions about life. Questions that are close to ourselves, but also to the cosmos that we inhabit. So we would like to invite all of you to join our finissage event of this Leiden Observatory exhibition called Close Cosmos. The finissage will be held virtually, most likely on the 19th of December. Maybe it will be 20th of December, but please subscribe to our newsletter, and then you will receive soon the official invitation with where the time and program will be also mentioned. Here you have a sneak view of the exhibition where we have Illuik lander with the Moon Gallery prototype, and also there are all these tiny cubes securely exhibited within this glass boxes. So we will give you then during the finissage once again the tour of the exhibition, but there will be also many other interesting things to discover. We will organize a small symposium similar to this. Yeah, so very much looking forward to that and seeing you all there just before the Christmas holiday.
So here you can see a quick overview of a few of the results of the Moon Gallery open call. And we would like to update you about the events that have happened during, since the this whole Corona situation have started, which we are quite proud of. One of them is the Moon Gallery in at Glassen House, which took place just after the first Corona measures were relieved. Another one was the Moon Water Gallery Festival in Aveiro, where we found a really great collaborator, and we're looking forward to have some new projects with our Aveiro friends. And the latest event, which Anna just presented, the Close Cosmos Moon Gallery edition. And now we would like to go deeper into a few of the artworks, just to give you a bit of inspiration and ideas about what kind of things our participants are thinking about. So this is a work called Last in brackets Bullet by Nick Ferro. And it is a small yet essential monument founded in commemoration to all the known and unknown victims of violence all over our globe. In placing this last fired bullet on the face of the moon as a token of faith and hope, we inhabit of our planet strongly emphasize the intention of not exporting our acts of violence to another planet.
The Gold Cube by Renzo Pasquale pays homage to culture and art in all its multitudes. It reflects on the places where science and art are taught, the university as a hub that transmits universal knowledge. Since the beginning, culture and study have been the values that have secured man's freedom. Gold Cube is a heartfelt tribute to the University of Padua, where Renzo, the artist, studied. Galileo Galilei also studied there, and he wrote his essays on the moon when he was a professor at the University of Padua. And he even mentions in one of his letters that in Padua he spent the best 18 years of his life. So Renzo dedicated the main site of his Golden Cube artwork to this famous Italian astronomer, Galileo Galilei. And with this artwork, Galileo, after more than 4 centuries, will look at the Earth from the moon. And he will remain an icon of science and astronomy forever. So this is a symbolic gesture of bringing Galileo to the moon. The moon will become the new starting point for future discoveries that are fundamental for human life. But we should always imagine the future without forgetting about the past. The gold is a metal that preserves the essence of eternity.
So this is a work called Elementa by Heidi Milani. Imagine having a backup of Earth on the moon, sorry. That's what Elementa is. This is a 3D printer structure, which will include 120 equal facets in which will be placed samples of all elements that can be found naturally on Earth to represent our planet itself on the moon for the future interplanetary generations.
Yeah, so when the COVID started, we had this special open call that was very much related to to this feeling of isolation and how can we feel comfort in these times. And because of course on the moon you would be also isolated, and we wanted to find some solutions for future moon explorers based on lessons learned on Earth today. So we very much like to show this example, a submission by Thea Boyarchuk, which is called Cat Purring Comfort MP3. And it reflects about how the importance of companionship with non-human animal species, and how this companionship was always transcending history from the domestication of dogs for hunting towards this cute cats that we have now at home, but also in our digital world that give us great emotions and keep up our spirits. In Cat Purring Comfort MP3 is a reflection on our non-human companionship and relationship with animals. This works consists of a waveform, as you can see, of a cat's purr, content and happy vibrations that are suspended within the cube. So this is this one of the most comforting sounds that we can take with us to the moon in this kind of symbolical sculptural format.
So since today there are not only artists or like people who are already part of the EarthMoonMars team, we would like to just a little bit present you the ways how you can collaborate with us. Of course, you can submit an artwork to the Moon Gallery. We are always very enthusiastic about all kind of ideas. Just go to our website, press the button submit, and we are really looking forward to the new pieces. You can participate in our workshop like today, but also what Anna announced, the workshop during the closing event of the Closed Cosmos exhibition. We are always happy when someone invites us for exhibition or a joint event. You can participate in an analog space mission also as an artist, which is very important part of our activities. And we can do a workshop or seminar at your institution, or you can just support our initiative. Thank you very much for attention. You can ask questions now or send them to the art@moongallery.eu.
Maybe due to the time constraint, not now, but I'd like to give a word still, even though Mark is reminding us that we have to hurry up. I'd like to give a word to one of the Moon Gallery artists who is here today, Mary Cowper, and she will also tell a little bit about her contribution to EarthMoonMars. But thank you.
Yeah, superb.
Okay. Hello, I made a very small presentation and I will go through it very quick, Mark.
Yes, I think it's great that we have some participants. I recognize also, so Isabella, Alexandra, we have Jamal, and so we have a number of participants to the Moon Gallery. So yes, we could put them all digitally on top of the Moon Gallery as well. Yeah. And clearly also we are looking at some joint event between Moon Gallery and the Iceland campaign. Huh?
Okay, this is what I was growing up outside in the countryside, always looking in the sky, to the moon, to the branches, to the birds. And this is one of the many, many pictures I took of the sky, including the moon, as you can see. the title of my presentation is Habitat on Earth. I always looked at the moon, but I work with nests. And well, nests is a kind of habitat on Earth, I think. It's the metaphor of the source of our existence. It symbolizes shelter, fertility, and new life. And it also refers to transience in nature. The nests I work with, I cast them in a mold, and I work with them, and then they will become bronze nests and sculptures. Oh, this was, oh shit, oh boy, I'm going through all the, wait. Yeah, because the pictures are down below. Yes, this is a final nest. But when I in 2018, there was an event by Bernard, and then I was asked also to join it. And the question that was asked was like, what do you want to archive for future generations? And how is the object of work of art a symbol of this message? And the work of art had to fit in a 1 by 1 by 1 centimeter cube. Well, that's very small because I worked with bronze, which is heavy, and nests are big. So I really had to think out of the box. And what is it that I wanted to archive? What has been important for mankind? What is still important for mankind? And then I thought, okay, ever since the existence of mankind, humans have explored their area. They wanted to expand across borders, sail seas, discovered new land. And now people want to visit and inhabit the moon and Mars. Well, I've watched a lot of space-related videos, and I noticed that engineers and astronauts were mentioning the word horsepower a lot while talking about rockets. And I really was amazed because I grew up between horses and, well, okay, I know what a horse is. I know that horse is power, but what is power? Where is it coming from? So I started to investigate, to read, ask questions to scientists. And while I was investigating, I came up with the mitochondrial DNA, which is the power plant in our cells, but it's also the power plant in cells of animals. Follicles of hair include mitochondrial DNA, therefore also in horsehair. And the horse has made our expansion on Earth possible. Within one century, the Industrial Revolution has made the horse redundant, and technical developments have opened the door to our galaxy and beyond. So this is how I came up to shape horsehair in an infinite circle containing the power of the power at cellular level, which will be used as a vehicle to send mitochondrial DNA to the moon. Thank you.
Yes, so thanks to the Moon Gallery and also to the other artists and contributors that are present with us. So we are really looking forward to the closing virtual event where each of you will have also a way to record for eternity your message, in addition with the one that we'll put on the surface of the moon within a few years. And also I understand that you have a collaboration with Iceland. So Moon Gallery, you are working with the Chile team to have an event that accompanies the EarthMoonMars Chile campaign. So how does it work?
We are now trying to get in touch with Iceland Art Festival, but unfortunately not yet very successfully. So
okay. Yeah.
But
yes.
still the idea is, of course, that Moon Gallery would like to be more actively part of also scientific and exploration events and simulations.
Yeah.
So we're really Iceland campaign would be really a chance for us to engage and to include the scientific as well as artistic results into this show, which we're thinking of.
Okay, good. And actually, I think the practice that EarthMoonMars and Moongaries, they want to be part of all astronautics events. So we'll have one in Paris. We will have one also in Torino, Padova, that you have mentioned. We will have it in Iceland. We'll have it in St. Petersburg. So the idea that each astronaut that leaves this Earth or that goes in an extreme place should bring along a Moongary. Isn't it your strategy at the moment?
Yes, but we're bring along for sure that we already have practiced. Also, Moongary was a part of the High Seas campaign, where our Branko, who happened to be both artist and the commander at this mission, brought the Moongary along with her. But we're also looking forward to more engage and give the artists opportunity to think of a more collaborative approach. What can actually happen during the campaign itself? Yeah,
excellent. So thank you very much to the EarthMoonMars and Moongary team. So now we'll pass it over the floor to the organizer of the next session, that the EarthMoonMars Iceland Chill Ice, nice acronym. And so we have the captain of this group, so Sabrina, Charlotte, and Mark. So the floor is yours.
Yes, thank you, Bernard, and thank you to the EarthMoonMars team. I think we can all agree with that standpoint that it's very important to work as interdisciplinary as possible.
May I make a request? Can you put all your camera on, and I can catch a gallery with all your portraits? Maybe we will send that also to the moon. And then
and that's also very nice for the small discussions that we will have later on.
Oh, yes.
Okay, so I hope everybody can see my screen now, and I think I am correct to say that my screen is very black right now. So let's see if we can continue in the presentation about Chill Ice. And as Bernard already mentioned, Chill Ice is a very nice acronym, so thank you for that. And it stands for the construction of a habitat inside a lunar analog lava tube. And as already mentioned, it is the Iceland campaign of EarthMoonMars. In very brief overview, what our mission will be about. There are actually multiple phases in our mission, and we can say that we have completely finished the first few phases, or well, completely. There's always more to discover, but we have discovered suitable lava tubes for a habitat or for a settlement that could also house humans, both on the moon and Mars, but also here on Earth. And one of those lava tubes is on Iceland. And this is also the lava tube system that we will be discussing today. So we have conducted some research into the habitability of a whole settlement inside a lava tube, and we will launch a prototype mission later, actually next year, in 2021, and we will have a very short simulation campaign where 3 astronauts will spend 2 nights inside a small lunar lava tube habitat, but then of course still on Earth for now. And we are also fostering our international collaborations with the EarthMoonMars team and with the Chill Ice mission team. And as I said, the overall goal is to build a habitat inside a lava tube in 8 hours. But this, of course, also raises a question. Why do we want to go into a lava tube? As you can see in my background here of my speaker image as well, I have very cool lava tubes, but they can also be quite hard to get into. Why do we want to go there? And this has mainly to do with the protection that you would require to live for a longer term on the surface of the moon. You need to protect yourself from micrometeorites or even larger meteorites, such as the cute little dinosaurs here. But you also have the problems of radiation, such as the solar activity, but also the background radiation. Another problem is regolith. This is the very fine-grained dust that you can find on the lunar and Martian surface, which is actually carcinogenous, so you don't want to breathe that in as a human. And lastly, you also need some form of thermal insulation. As you can see in the little diagram here, there's a difference in temperature of almost 300 degrees Kelvin, which can be very tiring for your metal alloys. So you would need some sort of very thick shell to protect yourself from all these kinds of environmental hazards. But again, if you want to bring a very thick shell to the lunar surface, it will also be very costly. So in terms, again, the costs, in terms of efficiency of both time, energy, and money, it would be very cool to look into the perspective of lava tubes. So I think I've said the word lava tubes over 11 times now, but maybe not everybody here is a geologist, and maybe not everybody knows what a lava tube is. So I will give a brief geology lesson. What happens is you have a very low viscosity lava flow. So this is very liquid-like, and it just flows over the surface of the Earth or the moon of Mars. And of course, the outside is much cooler than the inside. So this will start to form a very thick shell around the lava tube, which then will still continue to flow on the inside. Because of this shell is quite porous, and it will act as an isolative layer. So the inside will stay warm, the outside will stay cool, and the crust will just get a little bit thicker and thicker. And eventually the lava flow dissipates, and you have a hollow tube where you then, of course, can live in. At least that's the idea. But why do we want to go to Iceland? Why have we done some research with the high seas in Hawaii? Well, geology lesson part 2 is now coming to you. And this takes us back quite some time to the beginning of the Earth. Very roughly stated, the Earth was filled with heavier and lighter elements, which I have made red and green in here. And then it was struck about 4.5 billion years ago by an impactor, which is called a Theia. Then for a brief moment of time, the Earth had cool rings, but the rings started to cluster and form the moon. And this is the moon as we know it today. And due to the plate tectonics and volcanic activity and the larger gravity field of the Earth, the heavier elements such as the iron and the nickel started to sink in towards the core, and we have a differentiation between mantle and core. And as you can see in here, the mantle is a little bit more enriched in the green stuff, so the lighter stuff, and the core is heavier in the red stuff. And eventually the moon also differentiated, but not as strongly as the Earth. And because of a lack of plate tectonics and volcanoes, you don't really have such a strong differentiation on the surface of the moon. So if you want to have a similar composition of the rocks that you can find on the moon on Earth, you want to avoid the continental crust, which is yellow in my diagram here, and you do want to have a nice little mix of mainly green stuff, so mantle material, and also a little bit enrichment in the heavier elements such as iron from the core. And that is actually why we are going to Hawaii and why we are going to Iceland. They are both oceanic islands, so they are formed with oceanic crust. And the oceanic crust is actually just mantle material welling up. So this is, relatively speaking, the green stuff in my image, but both of those islands also have a mantle plume beneath it. So this is also called a hotspot sometimes, which actually takes up some of the core material and some of the heavier mantle material up as well. So that's how you can explain some of the red stuff and the green stuff without having too much of the yellow stuff. And that's why Iceland, in my very simplified geological eyes, is mainly red and green. So, as I said, we have lava tubes on Earth, and some of those lava tubes on Earth are actually quite big. Some of them are formed to be over 2.5 kilometers long and can sometimes be up to 25 meters in height. But even on the moon and on Mars, we can have lava tubes, and due to the lower gravity, they can be much, much bigger on the moon and on Mars than the ones that we find here on Earth. You can see some images of lunar lava tubes in here. And the hole that you can see on the left, so a hole into a lava tube, is called a skylight. And this is actually almost 300 meters deep. So we can not only have just one very small lunar settlement inside a lava tube, but even the whole lunar city. But even looking further than just the moon, this is a topographical map of Mars. And on the left side, you can see Alba Patera, which is located on Alba Mons, which is one of the biggest volcanoes that we have. It's located quite close to Olympus Mons, which is the highest volcano that we know of in our solar system. And on the west side of Alba Mons, you can see there's a very large flank, which is thought to have over 180 different lava tube systems, as you can see in the little scribbly drawings on the big picture here on the left. So also on Mars, there is plenty of opportunity to go into a lava tube. And there's another amazing thing in lava tubes, and that is the research that can be done in there. Because of the protection that the lava tube offers, the inside of the lava tube has not changed at all since its formation, other than by secondary processes such as the atmosphere or maybe even life, which we can find here on Earth. If you shine with the UV light in some of the lava tubes on Hawaii, you can see trails of living stuff lighting up. I sadly do not know what kind of living stuff this is or what kind of precipitates from the living stuff this is. I'm not a biologist, I'm a geologist. I can tell you a little bit more about the rocks if you like. But I do know that this is an indication of life. And that would be so cool if we could also maybe find some of this remnants of fossil life on the moon and on Mars as well. That's why we are hosting Chill Ice. So as I already said, Chill Ice stands for the construction of a habitat inside a lunar analog lava tube, and it's the Iceland campaign of EarthMoonMars. Also unveil our logo, and this is not it. This is still one of the very first designs. So for Chill Ice, where do we want to go? So as I have said, we are going to Iceland. And on the picture here on the left, you can see some of the skylights of the Stefanshellir lava tube system, which is located in the lava field of Hallmundarhraun. This is about 2-hour drive from Reykjavik, so the capital of Iceland, and it's located in the western part. This is what the inside looks like of such a lava tube. And as you can see, there is also some water ice present here. And we are hoping to have some water ice available also on the moon and on Mars. This would help us, of course, to feed ourselves and to water our plants, but it could also option in as a way to produce oxygen to breathe or make hydrogen for rocket fuel. So a very brief overview of the mission. We will have several days of preparation and analog astronaut training inside lava tubes on Iceland. We will have a very short 2-day simulation where 3 astronauts will spend 2 nights inside one lava tube habitat in the subsurface of Iceland. And of course, we will have extra days for outreach and information exchange. And then we hope to launch another short simulation campaign of, again, 2 days in case anything goes wrong, or to maybe do it even better on the second try. And lastly, we will have 2 days of wrap-up to make sure that we leave our environment as clean as it was when we found it. And this is, of course, very important also if we want to go to the moon and to Mars, to not destroy the environment, but to respectfully treat it. And of course, eventually we will do some national and international outreach. We will publish our results. And if everything goes well, and let's just hope it does, we will continue with a more permanent space analog habitat where we can host researchers. So we have had a lot of help already from, of course, EarthMoonMars and ILUIC, but also from the VU Amsterdam, Reykjavik University, IPSA Toulouse, the TU Delft, Kwantlen Polytechnic University in Canada. But we also need additional help in sponsoring, and we hope to have you also as one of our co-sponsors. So feel free to go to our GoFundMe page, which you can find here. And I will also share the link in the YouTube live stream soon. And now the big moment arrives, because as I have already said in some of our emails, we will also unveil our logo. So this is just the draft of our logo. It is not the final version yet, but I am not sure if I can make a drum roll sound. Here it comes. So we have to thank Esther Konijnenberg, one of our newest team members, and her sister for the amazing design of this logo. And as you can see, we are picturing ourselves looking back at Earth and looking forward to Mars while sitting safely in our chill ice habitat inside a lunar lava tube. Okay, so to conclude the presentation of Chill Ice, the mission, we will focus on the exploration of lava tubes, mainly on Earth, but eventually also, of course, on the Moon and Mars. We will help to develop the technology that is needed to successfully live on the lunar and Martian surface. We can only do this, of course, by focusing on the human well-being. And again, this is not only looking into the keeping humans alive on the lunar or under the lunar and or Martian surface, but this is also looking back to Earth. How can we use space technologies to improve life on Earth? And eventually with the goal of settlement preparation and later on solar system colonization to spread our wings beyond the Earth and possibly even beyond our solar system. And that is also our slogan of the mission, from into the Earth to into the universe. If there are any questions remaining, you can feel free to contact and reach out to EurMoonMars. Please do not forget to go to our GoFundMe page and share it and donate. And if you want to get in contact with us, send an email to info@chillice.com.
Everybody, can you prepare like a 30 seconds to introduce yourself? Okay, I will start with maybe Alexandra Arstanskaya. You want to introduce yourself, as you were also mentioned as part of the Moon Gallery?
So it's nice to see you online, and thank you for presentations. Yes, I'm a visual artist. I'm based in The Hague, and I'm participant of the Moon Gallery for 2 years, and really admiring to see new projects. Yeah, my project is devoted to spatial perception, and it represents the vanishing point as a key term of this understanding, because I wanted to bring it there as a part of our perception of space. So then, because it's very specific for human being and for Earth particularly. So this is my idea behind.
Excellent. So we had a long-lasting collaboration with Alexandra. Also, she is a visual, real-time performing artist. And we have some event where we mixed space, music, and our visual digital art in real time. We hope we are going to do that again soon. Huh?
Yeah, I miss it a lot. I miss it a lot.
Excellent. So let's, I'll go alphabetically. Annelotte Wert, yesterday you gave a presentation on results from EurMoonMars. So maybe you can introduce yourself to the rest.
Oh, yes. So I'm Annelotte. Yeah. I am a geologist from Amsterdam, and I'm going to give a presentation in a few minutes. So then you'll learn more about me.
Excellent. We have Christophe Enes. Yeah, you gave a talk yesterday on your exoplanet research. You want to introduce yourself? And then I'll go alphabetically. I'll go to Esther and Jamal and so on.
Okay.
Christophe?
Yeah. Hi, everyone. I'm Christophe. I'm studying AI at the University of Amsterdam, and I'm doing my thesis on exoplanet research, applying AI to characterize special exoplanet transits. Yeah, exactly.
Excellent. Are there some AI production of artwork that we could then send to the moon, or even produce art in real time on the moon on its own? Oh, we have to start a new department at the Faculty of Amsterdam, maybe AI and arts. Huh?
Yeah, maybe that would work.
Okay, so let's ask Esther Koneinenberg.
Hi. Yeah, I'm going to present in a few minutes as well. Yes. So I'm going to leave it then.
Okay, so you're getting ready. Good. Then we have Jamal Agheli, also long-time collaborator.
Hello, thank you very much for the presentation. Hi.
So how are you doing?
I'm doing wonderful. I'm calling from a photo shoot right now. Yeah, I'm the photographer for EurMoonMars and Moon Gallery collaborator. And also part of the coming Chill Ice. And already thank you very much for the nice presentation about the coming campaign.
Yeah, and also you are in the EarthMoonMars, and as you have seen that we have a number of astronomers that have joined us, also giving us access to large telescopes. So I think it will be good to reconnect with you, Jamal.
Exactly. Yes, I'm at the moment doing the more amateur astronomy section of EarthMoonMars, and for the public outreach events.
And by the way, for the closing event of the 20th of December of the Moon Gallery, this will be also the time where Saturn and Jupiter will be the closest at 3 arc minutes, so 1/10 of the sun, as they have never been since Middle Age. So I think we should all observe it. Yes.
Exactly.
So okay, so we make a competition on that. So we have okay, Nabel Rias.
Hello. Hi.
Hello. Hello, Nabel.
Hey, yeah, so I'm part of the Lunar Zebra team. I'm not sure if some of you know, but we were involved with the Hawaii mission earlier on in the year, and we're hoping to be part of the Chill Ice one as well. I'll go into more detail
in your presentation. Excellent, excellent. Okay, so we have also Purik Moon Law that I had the pleasure to meet in Vienna during our Space Habitat workshop organized by Sabrina.
Yes, hi everyone, I'm Purik Moon Law. I'm an aerospace graduate from the University of Applied Sciences, Wiener Neustadt, which is in Austria. And I came to know Bernard and Sabrina through the EarthMoonMars workshop, which was held in Vienna, I think 2 months ago.
Excellent. So we have been also joined by Selene Canelli. I have met through the SGSC mentorship program. So it's nice to see you today. Selene, you want to present yourself?
Hi. Yeah, sorry, I was outside getting some olives.
Okay, olives.
Yeah. So I'm Selene. I just graduated from a Master of Molecular Biology from the University of Queensland in Australia. And I also hold a Bachelor in Archaeological Sciences from the UK. So I'm like bioarchaeologist / astrobiologist. And I'm part of the SGAC network. So that's how I came, as I said, to know Bernard. And yeah, I'm looking forward to start a PhD in astrobiology in the upcoming year, and as well be part of an analog mission.
Okay, so yeah, we need astrobiologists in our analog mission, as you have heard from Mark. There is ice in these lava tubes, but also we can conduct astrobiology experiments in laboratories. So we need always one astrobiologist in the team. And then we have Ike Rusticus. We made a presentation yesterday.
Yes, I'm Ike. So I'm a master student in artificial intelligence at the University of Amsterdam as well. And I'm writing my thesis currently about applying AI for improved planet detection.
Good. So it was a way to see the audience. And so there are other participants like Robert, but they are going to give a talk. Huh? So I'll let you introduce them as part of the Chill Ice core team. So back to you.
Yes, thank you, Bernard.
And now you know your audience. And okay, you are in charge.
Yes. Okay. Thank you very much. Then we will continue with the program. Our next speaker will be Roberto Landolina from Italy, and he will present some of his previous works and also what he is going to do for our mission of Chill Ice next year. Roberto, please share your screen and unmute.
Good afternoon. I'm Roberto Landolina. Today I will talk about my thesis work for the EarthMoonMars group, and in particular my contribution for the Chill Ice mission next year. And I will talk about the mission analysis and with a focus on the stakeholder analysis. So how we would like to involve our sponsor and why we are doing that. So basically, first of all, a short introduction to me. I'm a master's student at Politecnico di Torino in aerospace engineering, and I'm developing my thesis on the field of habitability and in particular smart habitat design. And that is the reason why I'm doing this collaboration with the CLICE work, basically, to design and to prepare for the mission next year. And as an intern of EarthMoonMars, also I'm participating in analog missions and analog simulation to study system and problem related to habitability and growth in general. And also I'm supporting for outreach activities in north part of Italy, for example, Torino, Milano, and Padua. The first things is to show my roles in CLICE campaign. So basically I will analyze the missions. So that means basically to identify stakeholders, to identify their requirements, so the needs and the constraint, and to define the CONOPS, the concept of operation, the architecture, and then to design the habitat. As a system engineer, I'm working also on the design and sizing of systems. And in this slide, you can see the function for each role responsibility. And finally, also outreach, because it's very important nowadays to inform our sponsor and public about our project. We can go on with a very short show how to design missions. This is the very common EASE approach. So we have basically 5 steps, 5 phase, which is the feasibility, to understand if it's possible to design the missions. So starting from the stakeholders to the objective of missions and the context. Then the preliminary design, so an overview of the whole missions concerning both the architecture and CONOPS and also the requirements. And then the detailed design, which is taking into account the design of all systems and to verify if the requirements are meted in a first moment. Then the assembly, integration, and test phase, which is the production and verification, where the component is assembly with the other parts, and it is verified if the requirements are meted, and then the operation and the disposal, which are the finally steps very interesting to get all data. Here you can see the very common EASE approach, and you can see the activities for each phases. And here, what I said, it is important to say that in this phase, the phase 0, we have to analyze the missions from a very theoretical approach, studying both the scenarios, the objectives, and the stakeholders. And that is the reason why I would like to talk about stakeholders. Here you can see the most common stakeholder in a space project. We have the space agencies, for example, ESA or NASA. We have a university, very common involved in our process, for example, Polito, MIT, and the University of Amsterdam. Study groups and association, for example, Asclepios, Moon Village, Mars Societies, etc. And the big companies like Thales or like Skidmore and Owings Merrill, which is developing the concept for future habitat on Mars in collaboration with the ESA. And others like the general opinion and the not space related companies, because nowadays they are very involved in social uses, in social facts. So maybe they could be interested in helping us to build a new vision for the future of the space exploration. And how to analyze that? Basically, we have to build, this is a very common approach. And you can see we have to identify the stakeholder, to give them a value, to define the value and the needs. And then we have to classify this stakeholder in basis of interest and influence to build these metrics and to understand which are the main stakeholder for us, which give us an overview about what we have to focus on during the missions. And then we have to understand which are the main needs in our missions So we have to understand what is most important to develop during our mission. If, for example, to reduce cost instead of reliability, or to produce something that is very important to, for example, new technologies instead of, for example, something that we have already designed. And this is the first part of my research that I will start to carry on in the following weeks with the Sea Lice group. Thank you very much.
Thank you so much, Roberto. If there are any questions for Roberto or some of our other speakers, and you are also in this Zoom session, please let us know via the chat and we can ask them to our speakers. I see that there are no further questions, so then we will continue with our next speaker, who is our space architect on our core team, Sabrina Kerber from Austria. Sabrina, please unmute yourself and share your screen.
Hi, nice to meet you. I'm Sabrina. I'm a space architect from Austria, as Mark has already said. I was also part of the EMIS mission last December. I also want to say, if you have any questions from the side of our YouTube viewers, you can easily just comment in the YouTube section. We're keeping an eye on that, and we're going to reply either in the chat or in here directly, so you can hear what we've got to say. Okay, and now I will start my presentation. So I am talking about what we need for the habitat that we want to deploy in chill ice. So what are the requirements if you're planning a subsurface habitat? Yeah, so I think you can all imagine that designing a habitat on the moon is very, very different from designing a habitat on Earth. But then if you want to design an analog habitat, you have to combine both of those things. So this is, again, another completely different approach that we need. So I did a bit of I kind of prepared to explain to you how we would approach a lunar habitat and how we would approach a terrestrial analog lunar habitat. So there's a bunch of really important technical requirements for constructing a lunar habitat. We have a bunch of shielding for radiation, micrometeoroid, extreme temperature. We need a pressure bladder to pressurize the habitat itself. And of course, there is really a lot of other life support system that is involved in a lunar habitat. We also need to make sure that we can manage the launch, the landing, and the construction on the moon. So you imagine that all of those things are also important for an analog habitat, but in a very different way. So first of all, for the analog habitat, we need to ask the question, what kind of analog research will be done in the habitat? So are we researching anything that's concerned with the shielding? Are we doing any of the experiments concerning the construction process, maybe? Then the analog habitat needs to be constructed in a very different way. We have to answer to those things. And also really important are the habitability requirements. So for a lunar habitat, we need to make sure we have, for example, sufficient habitable volume per crew member. We need to have work and research areas that allow for the mission needs. So is this a research station? Is it something made for tourists? It kind of depends on what mission we have. And the same can be said for an analog habitat, but here we have to allow for a much broader variety of experiments and research experiences, because the research that we do there can change from mission to mission. We also need to make sure, of course, that we have enough privacy and personal space. And for this, we really need to keep an eye on the research time frame. So is it a long duration mission, a short duration mission, or do we target to research special time frames as in the Chill Ice project? So you can see we have the research categories: science and technology, art and culture, and sociology and behavioral parameters. All of these can be done in one and the same analog habitat. So for example, in the high seas habitat, there have been research experiments in all of these categories. And I think it's really important to keep in mind that for chill ice, while we are targeting different research categories, we have a very, very special time frame. So we are focusing on those first hours and first days after arrival. So it's a very short duration mission. And this, of course, has to be minded in the planning of the habitat. And in those first hours and days, one of the main researches that we are going to do is focused on the deployment. So is it possible for the 3 astronauts to deploy the habitat themselves in those 8 hours? So this is pretty much the baseline that we have for how we want to design the chill ice habitat. One thing that is very, very important is, of course, the deployment site. And Mark already told us everything about the lava tube that we're going to be in. And it's just very important to keep in mind that we have some size restrictions that are given to us by the natural environment. So, for example, the habitat itself in its deployed state must fit in here at the chosen place of deployment. And this makes it necessary to keep it smaller than 7.5 times 4.6 times 5.1 meters, which is actually quite doable for the mission that we're planning. A more restricting limit is the entrance passage. So we also have to make sure that we can bring the habitat into the lava tube while it is still in its packaged state. So this does give us a bit of more room to play with, but we need to make sure that it can actually fit through the most narrow part of the passage, which is the entrance passage with 1.7 meters of height. So this will be a very limiting factor that we have to keep in mind. So while we do not need to provide a pressure bladder or shelter from extreme temperature of the moon, we still have some temperature and humidity issues. So you can see our collaborators from Iceland already did some measurements for us in the lava tube, just so we know, okay, this is what our habitat, what our analog habitat needs to protect the astronauts from. The habitable volume is again a very limiting factor in the design process. And we just have to really make sure that it is made for 3 analog astronauts for 2 nights at least, and that it is also possible to launch it to the moon, so to speak. So we need to be able to transport it to Iceland and into the lava tube. So keeping this in mind, we were able to develop a room schedule. So what is it that we need to have in there? What's the absolute minimum that we need in such a small habitat for only 2 nights? So we're gonna need some hygiene area. Of course, this is not gonna be a super fancy toilet with shower like we had in high seas, which was already quite limited and small, but at least we had one. So this is more or less gonna be an area that is shielded from the rest of the interior. We also need a minimum work and communications area, something where we can do the research that we bring there. Of course, we need a sleeping area, place to don our EVA suits, some storage for the suits, and of course, a simulated airlock. So the most important thing, if you want to look at the room schedule, is definitely going to be multiplexing. So we have to use the same area for multiple things. So it needs to be flexible. The area where we sleep at night will also be the area where we work maybe. So it will all be maybe foldable in some way or changeable in some way. So what is the maximum pressurized volume that we could fit into the size that we are able to bring into the lava tube? So this would actually be quite big, so 75 cubic meters. We can definitely go smaller. The minimum pressurized volume that we are going to need, though, is 7 cubic meters. And we kind of oriented that on the lunar module of the Apollo mission, which had pretty much the 7 cubic meters as well. So we should not go smaller. Yeah, so what structures are we going to target? What are our collaborators maybe going to do for us? There is a broader variety of systems that we can choose from. It will definitely have to involve something deployable, something unfoldable. So I put some examples in here so you can see, for example, here the pneumocell from Thomas Herzig. So a pneumatic structure can be deployed very, very fast. we have the example actually done by Anna Sitnikova, who talked before in the EarthMoonMars session, which is an origami tunnel that they tried to deploy at ESTEC. And this is also a system that works very well and is possible to deploy it very, very fast. And as you can see, the big space agencies have done a lot of research into that direction. And I also think that to choose a hybrid construction would also be very interesting. So we have some rigid shells here that can be deployed to bring quite a large volume. Of course, this would be too large for the high seas habitat, but the system is very, very compact and very efficient. So keeping all of those in mind, it is very important that a packaging and a redeployment is possible for the missions that we intend in chill ice. So it needs to be possible for the analog astronauts to deploy the habitat, live in there, and then package it and bring it outside again, because we want to do another mission with the same habitat, again testing how the analog astronauts are able to deploy the habitat in the 8 hours and then do research in there. So I'm really curious to see what final structure we will come up with, and I'm looking forward to working together with our collaborators from Canada. We will be hearing from them towards the end of the session, because of course there's a really big time difference to Canada. Thank you very much.
Thank you so much, Sabrina. I think this was a very insightful presentation. Yes, and of course, please also reach out to us on our social media, which is also partially or largely in the hands of Sabrina. So please reach out to us and we will get back to you.
The Chill Ice project will be featured on the EarthMoonMars social media. So if you're already connected, keep your eyes open, or otherwise do follow us for more updates. We're targeting a very dedicated Chill Ice outreach campaign over the next month. So you will be hearing a lot about Chill Ice on there.
Okay, great. Thank you so much. Then we will move on to our next speaker, Annelotte Weert, a geologist from Amsterdam, who was also first MS mission in Hawaii, and she will also be part of Chill Ice as one of our analog astronauts. Annelotte, please tell us a little bit more about your research and share your story.
So, yeah, like said, my name is Annelotte Weert, and Charlotte asked me if I want to contribute to the Chill Ice mission as an astronaut, and so here I am. I'll tell something about myself. I'm currently enrolled as a master's student at the Vrije Universiteit in Amsterdam. I'm almost finished with the program. Yeah, I did fieldwork in Spain, Greece, on Svalbard. So here you see a picture of me in action during that time. And of course in Hawaii, where I was crew member of the first EarthMoonMars High Sea mission. And if you want to see how that was, you can watch Space Drop on Amazon Prime. It was, yeah, the movie was made during the time me and the crew were there. So really nice if you have some leftover time. And now I would like something to tell something about my master thesis, for which I did fieldwork during the high seas mission. So here you see some rocks from Hawaii. You can see that there is no brown layer on the left two pictures, and there is some brown stuff here on this picture. Well, this brown stuff, this is yeah, these are formed by the interaction of the rock with meteoric water, and that interaction forms hydrated clays. When we put the rocks we take at Hawaii, when we took them home, we put them under a spectrometer, and you can see the results from this inside this picture. Here you see all the different lava flows I've sampled, and I made scans of them. So you can see this brown layer over here, which we just saw in the picture. It becomes thicker when the samples get older. And when we look then to the spectra of the rocks, the same rocks, we can see that inside these brown layers there are hydrated clay minerals present, like I just said, but here this data, it confirms what I'm saying, so it's not rubbish what I'm saying. So yeah, you can also see that the blue dots, they increase when the lava flows get older. And well, how do these minerals form? Well, the meteoric water, it interacts with the rock and dissolutes the basaltic material, therefore ions are yeah, taken up into the solution and then are yeah, then precipitate secondary minerals inside pores that are present inside these nice rocks. Well, why am I telling this? Because on Mars we have found these sort of clay minerals as well. Here we see some spectra from Hawaii, and these are spectra below. They are taken from orbit around Mars, and we can see that the same types of minerals are found. For instance, this smectite specter looks like the smectite specters I have found on Hawaii. And also when we are looking to the chemical data of the samples, we see that the pink dots, which represent the Hawaiian samples, they plot yeah, on the same places as the Martian samples. So these data sets are taken from Mars by the Mars exploration rover Spirit and Opportunity, and there are some data from meteorites as well. So the data from Hawaii represent the composition of the yeah, of Mars, at least these samples from Mars. So yeah, then we can make some comparisons. So here you see some. In the left picture, we see a diagram that represents the weathering trends on Hawaii, and we yeah, those are indicated by arrows because the lava flows on Hawaii are not that old. We cannot see big trends. However, in literature, there are also studies of older flows, therefore we know the trends will be something like the arrows indicate. But when we go look at the samples from Mars, which are really much older, we do not see the same weather trends. So although there are the same type of secondary minerals, we do not see the same alteration patterns. So the minerals there form at another way, which can be due to a different climate or a different pH values. Yeah, so there's still big discussion going on about that. And yeah, it's yeah, yeah, so therefore I want to conclude my talk now. And yeah, this is also some sort of research which can be done on Iceland, as the lava tube is also formed inside basaltic material, just like these samples from Hawaii. And inside the tube, you can also find some sort of secondary deposits which can be sampled and then also compared.
I think this goes very much in depth into what kinds of cool stuff we can do and what we can learn from the rocks that we can find here on Earth, but also on the Moon and Mars.
I have a
I would like to.
Oh, you may have a short question.
One short question, please.
Even though you work with me and a lot, but now in the context of chill ice, do you expect different alteration product if you have alteration by liquid water or by ice?
Well, in the end, it's still the same chemical composition, but so the alteration product would be the same, but the way it forms can be different, because when water goes inside the rock and then it will and it freezes and becomes ice, it expands and therefore can crack open a rock, and then when it becomes water again, it will alterate the rock faster, because there is more surface to alterate, then the rock will be cracked open.
Yeah, okay, thank you.
Yeah, that's very interesting kinds of physical weathering we might also have on the Moon and on Mars. Okay, then I would now like to introduce our next speaker, Purichmun Lo. He's a mechanical engineer and designer from Vienna. and he is also in our core team. Please share your screen, Purishman.
Yes. Right. So thank you for the introduction, Mark. My name is Purishman Low. I'm an aerospace graduate from the University of Applied Sciences, Wiener Neustadt, in Austria. Outside the realm of my academic study, I am an SGAC member. So I'm working as a HR over there. And as well, I just recently joined the 2ICE mission. I was involved extensively on CubeSats during my master study, so where we were building 3U CubeSat. And an ongoing project that I'm currently working on, which is called Lexicon, lunar extraction in a closed environment. And I would like to talk more about this project in the next few slides. So what is the problem that we are trying to tackle? So as we know, on Moon, there's almost zero gravity. So water extraction can be a very challenging process because of the amount of dust, which poses a carcinogenic hazard and as well existential threat to engineered systems or even the habitats. So we would like to perform water drilling excavation near the habitat, where we will collect the dust for future users to extract minerals such as aluminum, magnesium for in-situ resource utilization. We would like also to avoid the waste of solid water mixed with the regolith during the excavation process. And of course, we would like to collect the lunar regolith from the excavation process. About the mission environment. So as we know that the environment on the Moon is very challenging and harsh. So there are extreme changes in the temperature, near vacuum pressure, constant exposure to radiation, and ultrafine dust particles. So we propose a system which has a funnel-shaped dome, which is pressurized. So the drilling system will be attached to the inner diameter of the dome. The dome is going to be 3D printed, and it has outside diameter of 1.2 meter, an inner diameter of 80 centimeter, and a height of 1.8 meter. The thickness is approximately 3 millimeter for the skeleton, and 5 millimeter for the top and bottom coverage. And the weight is approximately 9 kilograms. So how does the system work? So first we start with pressurizing the chamber with helium, since helium is a lightweight gas. Then we perform the drilling procedure, so where we start extracting water. Then we use the compressor to create a vacuum in the chamber so that the dust particle can flow through the piping system shown in this picture here. We have a filter, which is shown in this picture, to filter out the dust. So that so it means that the output of the filter is basically helium, and the helium gas can be reused again. So this project was born through and a hackathon that we participated. It's called Asclepius Hackathon, which was organized by the EPFL. We were the winner. Our project was chosen, and currently we are looking for sponsorship and partnership and suppliers. In 2021, we will start performing the tests at an analog mission at EPFL. After the successful test campaign, we will start raising awareness of our prototype or of our product through marketing, and we will hopefully send our product to the Moon in 2023. So these are my team members. And if you have any questions, or if you feel that our project can be beneficial to your work, please do not hesitate to reach out to us under this email. Thank you for your attention.
Oh, thank you very much. That sounds so cool. looking forward to 2023 and see how much we can actually safely and efficiently extract there. Thank you very much.
Thank you.
Then I would now like to introduce our next speaker, also a geologist from the VU in Amsterdam, Esther Konijnenberg. She will tell a little bit about her previous project. And again, it involves rocks. Yes.
So, hi everyone, I'm Esther Konijnenberg. I'm a current master's student at the Vrije Universiteit in Amsterdam. I am one of the newest team members of Chill Ice. So I will introduce myself to you. So I will tell a little bit about my study background as well. I did my Bachelor Earth Sciences at the VU in Amsterdam as well. My specialization was in geology and geochemistry. I had some field works in the Netherlands, in Belgium, and in Spain. In this picture on the right bottom, that's me in the field in Spain. It was not warm as most people would expect in Spain. It was 11 degrees. And last year I went to Norway for my minor. I also took a lot of hikes in the surroundings of Bergen. That's where I studied. And also I went to Preikestolen, which is also a beautiful geological sighting in Norway. Last year I also did my bachelor thesis. We were actually supposed to go to Greece, to a few islands to do some research there, but due to the COVID-19 restrictions, we couldn't go there. So it became a fully literature research, which was kind of boring, but I managed to do it. So I couldn't look to rocks at all. That was very, it was not motivating at all. But my bachelor thesis was about the correlation between geophysical and geochemical parameters at the South Asian volcanic arc, which is, of course, located in Greece. There is a major subduction zone at the southern edge of Greece, which is the African plate colliding with the Eurasian plate. And there's a lot of funny stuff going on. So we thought, let's have some further research. I didn't really put in graphs or anything because it's too much graphs to show you, and I cannot just show one because that would neglect the results I had. So I'm gonna just describe them. The four physical parameters that I looked at and that had the most correlation with the geochemical parts were the crustal thickness, the distance from the trench, the Wadati-Benioff zone, which is the earthquake zone, or zone in the subducting slab that has the most earthquakes, and the distance to the slab tier. In the subduction zone in Greece, it is the case that there is a tear in the slab which causes mantle, a fresh mantle actually, to rise up and get through the slab actually. This causes a geochemical composition alteration in the rocks along the pathway of the slab. So the further you go away from the slab tier, the less alteration there is. So there is a clear correlation in that one. For the earthquake zone, directly beneath the volcanic arc, there are actually almost no earthquakes. This is due to the partial melting in the subsidizing slab. So it's fortunate for the islands that they don't have that many earthquakes. The distance from the trench gives us a result that closer to the trench, which is the point where the African plate will go under the Eurasian plate, has more influence on the magma that's underneath the crust in terms of sediments, because sediments have different chemical compositions than mantle material, and that causes the rocks to alterate as well. So the closer you are to the trench, the more alteration there is in geochemical part. And the crustal thickness, it didn't really give us a straight answer to what the correlation was, but we found that a few rare earth elements tended to decrease in percentage when the crust became thicker. In the end, we actually didn't really know why this was, but it's a given fact by our observations. And in the concluding part of my thesis, it was actually not clear if the geophysical parameters were caused by the chemical parameters or if it was the other way around. But that was fine for us because further research can be done on this subject. So my current activity is that I'm a first-year master's student in earth sciences with the specialization in geology and geochemistry. I also try to take the track of planetary sciences because I'm very interested in the moon, in Mars, in other planets in our solar system and even beyond. So that also brought me a little bit closer to chill ice. Because Mark Heemskerk is a fellow student of mine. We have a few courses together, and I saw in a newspaper, the Volkskrant, that he had an interview with someone about his mission to Hawaii. And I read the article and I was very interested. So I texted Mark like, hey, how did you get there? And what are your interests? And what are your results of the research and those questions? And we talked, and then he mentioned the mission of Chill Ice and he explained what it was, and that got me interested. So I said to Mark, well, yeah, sure, I want to join. Yeah. So now we're I'm quite new, so I'm not sure in what activities I actually can help the team, but now I am focusing on the subsurface geology and the surroundings of the habitat. And I also, as Mark said in the beginning of the workshop, I together with my sister designed the logo for Chill Ice. And that was my presentation. Are there any questions?
Hey, thank you very much, Esther. That's a very cool presentation. And I think even though it might be a quite different field of geology with subductional slabs and slab tears, I think it might still, of course, be relevant to see the different kinds of geology that you can find on Earth and how we can better study them also on the Moon and on Mars. And then for now, I want to introduce our next speaker, Nabil Riaz from the Lunar Zebra team. Nabil, please unmute yourself and share your screen.
Brilliant. Well, hello. My name is Nabil Riaz, and I am part of the Lunar Zebra team, which is based in Delft. I am the partnerships coordinator and a student of aeronautical engineering. We at Lunar Zebra, we adhere to three main pillars: education, technology, and space exploration. We want to provide opportunities for the next generation of engineers whilst being at the forefront of cutting-edge technology, hopefully cementing our names in the next space race and furthermore history. First, let's talk about Zebra. What is Zebra? Well, the name itself is a Dutch abbreviation for zesbenig robot, which translates to six-legged robot. The concept was first introduced by the REX project from the University of Pennsylvania as a very robust form of locomotion. But there's more behind the concept of Zebra than just its locomotion capabilities, and that is swarming and miniaturization. The idea behind this is to develop small and relatively simple robots to perform complex and intelligent tasks as a swarm of zebras, kind of like an army of ants, collectively finding the shortest, easiest path to the best food source, and then putting all their efforts together to make sure it's a smooth model. Today, it's more focused on the three sections: the Strelka, which is our qualification model, Our past missions, such as EurMoonMars, the High Seas campaign, which was in February, and DECOS, a mission that's a lot more closer to home, which we'll go into a bit further on. Also, our future analog missions, such as Igluna, which is based in Switzerland, and obviously Chill Ice in 2021. Following up is just a quick little video of what we should expect. So Lunar Zebra has been making significant progress over the past few years. Currently, we're coming up to the finalized version of our qualification model, which will be ready for testing at one of our partners, NLR. Once we have the test results from that, we'll be able to develop our flight model, which will be ready for the launch in Q4 of 2022. Also, alongside this, we have our analog missions happening, Chill Ice in Iceland and Igluna in Switzerland, for Strelka, which will be the base for both of these missions. We've been able to achieve this because of our amazing team, a combination of multiple faculties and schools coming together alongside 65 students ranging from first year bachelors all the way up to professors and postdocs, all come together to help achieve our lunar mission objectives, which overall is that our rover will piggyback a ride to the moon with one of the private or National Space Agency moon landers. The main objective is to survive the harsh lunar conditions for 14 Earth days, 1 lunar day, and communicate directly back to Earth with its location and health conditions. In the 14 days, it will test out the unique locomotion capabilities of the rover and get some distance between itself and the lander to take an exclusive picture of the lander and Earth using its camera. While it's walking, the rover shall avoid craters and boulders bigger than itself by using onboard semi-autonomous navigation system. And at the end of the 14 days, the rover shall go into hibernation mode and will beacon at the end of the lunar night if it survives the minus 210 degrees Celsius. The project itself is split into multiple components: the antenna, the solar panels, the cameras, the chassis, the C-shaped legs, the motors, and the deployment method. All of these components have required Lunar Zebra to research and develop innovative technologies that are at the forefront of engineering. Now, why do we base ourselves more into analog missions as well? The main reason is the ability to test our new instruments, and where we do it, it's all over the world. The most recent one was in Netherlands, but before that, it was Hawaii with EurMoonMars themselves. And whenever we hear a mission that is similar to our goals in what we need to achieve, we're interested. We try and sign up and get involved. So a bit more about the past ones. You might recognize this picture if you read an article by NVR. That picture itself has Robert in, which is part of the EurMoonMars team, and it's based in Hawaii. So Lunar Zebra was one of the rovers that was tested in that campaign. The main objective for that team was to test the legs design, the robustness over rough terrain, and remote operations between our Delft ground station and then the base in Hawaii. Also, another mission was the DECOS, which was in May of 2020. The rover itself would walk on different kinds of grains, and it could even go downwards on steep craters. Going out of the crater, however, was more difficult. It would remove the rocks under the legs and slip on the spot. Eventually, we did manage to get the rover out, but that was by operating the rover manually. So that was just a quick introduction onto what we've done as Lunar Zebra and where we see ourselves going. If you have any questions, feel free to ask. Also, you can visit us on our website using the QR code and keep up to date with everything. Thank you very much for listening.
Very much, Nabil. I think that's a very cool project that you are involved in. I'm really looking forward to see how these small rovers can actually discover the lunar surface and also, of course, the lunar subsurface.
Yes.
I have a question. Did you do a specific test in regolith-like powder soil? Because is there not the risk that you are just diving down in lunar regolith?
Yes. So the testing that we done at DCOS, it was with varying amount of grain of dust. So it was from between 1 millimeter all the way up to 50 millimeters. Yeah. So in terms of with the facilities we have at the moment, we've been able to test to a pretty accurate degree of how it will react on that surface.
Oh yeah, okay. I was in the DCOS test, but I was seeing them. But on the moon, you have grain size, okay, 50 micron, really. Yeah. And so that's very important to test also the locomotion in those conditions.
Yeah.
Yeah. Excellent.
Okay, great. If there are no other questions, I don't think I've seen anything in the chat. We also should have an eye out on our YouTube channel as well. So I don't think there are any questions coming in. Then I would now like to introduce our next speaker, Thor Atli Vandal from Space Iceland, who is calling us in from Iceland, I guess.
Yes, that's right. Okay. Thank you. Yeah, hi everyone. It's an honor to be here with you. My name is Thor Vandal, and I am the director of Space Iceland. Space Iceland is sort of a DIY space agency in a country that doesn't have one. We're obviously not an agency and we're not part of the government, but what we are is a service entity to any sort of space-derived sector. So I'm gonna share my screen now. All right, so as I said, I work for Space Iceland. We are a service entity for the space sector in Iceland. So the problem that the space-derived sector in Iceland faces is that we do not have a national space plan. There is a considerate fragmentation in any sort of space-related authority. There is no specific policy or industrial development policy. And there is a huge amount of complications in doing most of the work. We have an underdeveloped legal framework as well. And sometimes we are just quite lucky that we're able to kind of mix and match certain things. And I'll talk a bit about that. So what we're trying to do is to link up the stakeholders and kind of foster this unified idea of a sector. And then we lobby the government to actually get a grip and get a bit of focus. Now, in sort of more developed areas or regions, that is still a challenge because it can often be quite difficult to have decision makers and politicians understand the benefit of space. I mean, often these things are quite abstract. And that's obviously the same thing that any sort of basic research faces when we're trying to find or discover new knowledge. It can often be quite difficult to explain how it's going to be utilized and then eventually monetized. So that's the challenge that Space Iceland spends most of its time and most of our day kind of trying to get through. So the way we work, it's divided in 3 different main roles. We are a space office, which is a service sector, and TILICE would be a good example of someone that uses that. We've been able to, and we've been quite fortunate to work with you guys and help you out sometimes and contribute, I hope. Then there's the space cluster. The space cluster is sort of on an ad hoc base. That's when we need to combine resources and kind of to further capabilities. The original idea behind Space Iceland was to kind of focus exclusively on that, but we soon realized that that would not be enough. So this is more of on a project based. Like we kind of do this on each project rather than having a centralized cluster, which is still an ambition of ours. And then the space lobby. The space lobby is all of our outreach. It's our cocktail parties. It's I've drunk more coffee since I started working here than ever in my life. It can be everything from lunches with politicians to meeting potential investors or talking to primary school kids or working with universities. This is astoundingly time consuming and has taught me to be a lot more patient than I used to be. So there are some priorities, and this is sort of what we set out to do. And this is still quite relevant, although there have been some new opportunities that have come to us. I mean, the main focus at the moment, the main political focus is joining the European Space Agency. The reason for us is simply that it gives us a political mandate. The fact that Parliament has passed a resolution that we should become members 4 years ago. And this is our sort of way of speaking to the politicians. This is what gives us a mandate, because without this, we kind of have to revert back to the fragmented policies of Iceland. We also, I mean, so Iceland is quite fortunate in the way that there is a lot of interest in working in Iceland. I mean, we do have some strengths, particularly in the fact that Iceland sort of looks like the Moon and Mars in many ways and has some of the qualities, although the air is quite a lot fresher in Iceland, I hope. So we respond to quite a lot of queries, and we kind of help target people to who they should talk to or to whom they should talk to, and often we kind of go with them. If you and it is kind of it's quite difficult to understand who actually makes decisions in Iceland, and the reason is simply that often the decision makers are not aware that it falls on their hands. So this is our sort of main priority at the moment and takes up most of our time. That's the sort of speaking to policymakers and then making sure that any project or anything that could happen in Iceland, that we can somehow contribute to it happening. That, I mean, basically to make sure that some project doesn't go somewhere else because no one responded to an email. So the model that Space Iceland is built on is quite unusual when it comes to space, because in most countries you will have some sort of space authority, and we are not a space authority. We actually can't really make any decisions, but we can use varied of methods to make sure those decisions are finally made. And the ESA application is a pillar policy project for us, because it does allow us cooperation on policy, on technology, on projects, and also for Icelandic companies or the companies that we work for. It is simply a buy-in into a market that we are not, that just isn't really available to us at the time. And the effect of this is that if you have anything that is somehow space derived, you are at a disadvantage if you set it up in Iceland. And that is despite the fact that we do have quite a big proportion of engineers. We do have quite a lot of knowledge. We do have a historical and a good connection, sort of historical and a cultural connection to NASA. You will be astounded in Iceland of some of the specific tech talent that we have, or science talent that we have. But what we do really lack is policy. So this is something that is quite important for us. And I'm just to kind of home in some of the activities that you could find that are space derived. Most of these will be downstream in Iceland. You will have, I mean, a typical summer will invite quite a few space agencies for testing in Iceland. Well, 2020 was a bit different. We didn't have as many science or field trips as we would normally, but we did have a sort of something that, well, we did have a big step where we launched a rocket from Iceland through the legal hurdle that is the Icelandic permit system. So Iceland doesn't really have a rocket permit. There's really no permit that says like you have a permit to launch a rocket. What we do have is multiple different permits, so you can combine, and an incredible amount of letters of no intent, or no objection, sorry, that will sort of combined allow you to launch a rocket. The problem that we are working on now, for instance, is that launching into space and launching just below the line is significantly different when it comes to permits and complications. So we're kind of mapping out whatever potential we have. And there is another example of how incohesive the policies are in Iceland. I can explain that a little bit. So here's some examples. Some of these are AI companies. Some of these are sort of like space logistics or space tourism. And then you have some engineering projects and scientific projects. Yeah. And then you have like smart cities and startup companies. So this is sort of what I have in my notes, but I wanted to tell you a bit about how the sort of what we are facing basically when it comes to space policy. So we put together a list of examples of how it kind of works, just to give you how it works. So it's very sort of fragmented. For instance, Iceland is a member of Copernicus, but it's quite underutilized. There's no sort of policy on adaptation or sort of how we use it as a strength. We have signed 3 major space treaties and rectified 2 of them. There's no national scientific plan, but Iceland actually did in 2019 participate in declaring space as a domain for NATO. So in a sense, through a series of coincidences, we do have sort of a military policy when it comes to space. So this is the environment that we work in, and my job and my colleagues' Alpha job is to just pretty much run faster than sort of the minefield of ludicrousness that is Icelandic space policy. And the service that we provide is exactly this. We link up people, we try to have an oversight of what's happening, we try to think of potential partners that could work together, and sort of through showing action and some activity, push, sort of raise the space sector's standing and focus so that we can lobby for a more permanent solution. So the model that Space Iceland is based on the fact that Iceland is simply underdeveloped when it comes to these things. But our industry and our scientists, they and some of our public agencies do actually punch well above their weight. And Iceland's legacy in space is actually quite impressive once you know that this is the environment. So in 1965, the French launched 4 rockets to space from Iceland. We've just been able to find all the documents on that in the National Archives and are going through them. It's quite a fascinating job, I must say, to be able to kind of go through these old handwritten notes and calculations by pen and paper, and some of the photos from that launch. The Apollo astronauts trained before going to the moon. There were 2 field trips here where they trained in geology. We do, well, this summer we launched a rocket for a company called, or with a company called Skyrora, going through the legal hurdles of getting that done. Quite frequently we do host these astronaut trainings, and currently Space Iceland is in cooperation with multiple other institutions and actually quite a few international partners looking into developing the first Icelandic satellite. So we see that as a sort of a big step in a policy project, where the first step of it is obviously consultation with stakeholders, where we take into account that this will be the first opportunity to actually design a satellite that kind of service our needs rather than piggybacking on another one. And then we are looking into financing. And Space Iceland is self-funded. We finance ourselves by charging service fee and members fee. They are, I mean, they are somewhat high, I guess, but we do bring quite a lot of value. And also there's an understanding among the members that certain things shouldn't really be charged, or the bill should just be written off. For example, a field trip that is a basic research or is doing something quite innovative and is struggling, that we shouldn't really stop that financially. So we do kind of try to help with financing as much as we can, and we do apply for funding or write sponsorship letters and so on. So that, yeah, that's pretty much Space Iceland. We are basically glorified office workers in space. So, and that's it's a job that is really an honor to do, actually, even though it can be quite frustrating at times. So I'll take any questions if you have them, and I hope I was able to kind of sell you Iceland as a good place to do field research in, even though it might seem complicated. But we are here to kind of streamline everything.
Thank you very much, Thor. Are there any other questions for Thor or for Space Iceland?
I would like to ask, if I may, how can we keep up with all your activities? Because you show some list, but maybe do you have like a website where we can have a good overview? Because Moon Gallery would be happy to collaborate on some of your projects, but yeah, I don't know, like, can we find somewhere good?
Yes. So at the moment, I would say just go to spaceiceland.is and sign up for our newsletter. That's the best way. We are also on Facebook and Twitter, but we simply have been so strained for resources, and we focus on kind of trying to ensure activities that we are not always the best at telling people what we're doing. We are working on it, and we are trying to kind of, well, we're trying to stabilize our funding a bit more so that we can hopefully add another person. So please sign up for our newsletter. It is always in English and Icelandic. We do have monthly meetings which are online right now. The next one is on the 7th of December, and they are always once a month. where we kind of discuss what's happening and then people can do introductions. So we do multiple events, and most of them are online as well.
Thank you very much. Then I think we have one of our core team members still largely unintroduced in some of her research. And I heard, Charlotte, you had a nice video of you together with Ana Paula de Castro, but some of your research you have done during the MS2 mission. So we have had MS1 and MS3, but I think MS2 is still missing. Could you please share the video with us?
So hi guys, thank you Thor for representing Space Iceland and giving such a nice talk. Yeah, so today my fellow crew members gave a lot of presentations about chill ice. So I hope for most of the people here, chill ice is a bit clear. If you have any questions, please go to Sabrina, me, Mark, or one of the rest of the team members. Last year, I participated in the analog astronaut mission in high seas called MS2. And me and my fellow crewmate, Ana Paula Castro, we recorded a video for you because she's in Brazil. And due to time delays and busyness, we thought it would be best to give the presentation together. So I will share my screen and enjoy the video.
Hello, everyone. My name is Ana Paula.
Hi, everyone. My name is Charlotte Pauwels.
And welcome to this virtual edition of EarthMoonMars workshop. Today we're going to talk briefly about our experience as analog astronauts with MS2, which was the EarthMoonMars in high seas. This was the second edition, and we just present briefly the research we did and other activities. So our team was mainly women. Our mission commander was Mikaela Musilova. I myself, I was the chief engineer. Charlotte was a crew physicist. Sabrina and Ariane was a crew engineers as well, and also space architects. And the only male on the team was Joseph D'Angelo. He was our chief medical doctor, and he was a great addition to the team. Our mission was a lunar simulation that happened last year from the 8th to the 22nd of December on the high seas habitat in Hawaii.
So our main base was located at Aztec in the Netherlands, where also our remote control stayed around during the mission itself to support us with rover and drone tasks. But the mission itself took place, as Anna said already, in Hawaii in America. As you can see on the map, it's quite a distance. So we flew there from different countries. So Anna is from Brazil, I'm from the Netherlands, but we also had people from America and from Germany and from Vienna. So we stayed at the Blue Planet, and then we went to Mauna Loa, which is a volcano at Hawaii, where the habitat high seas is built on, where we conducted the analog astronaut mission and its research.
All right. So just to talk briefly about my own research and activities as a chief engineer, I was mainly responsible for the habitat equipment, that meant power systems, solar panels, inverters, generators, everything inside the habitat, and also to ensure nominal operation of our EVA equipment, which stands for extravehicular activity, which is everything we have to use when you go out of the habitat, and we do that for many reasons that we talk about in a minute, and also to check all this equipment before and after we leave for an EVA and go back from it, and also to gather the feedback from the team to see if all the communication systems were working, if everyone was hearing each other fine. Also, I would need to provide mission control with daily engineering reports, myself as the chief engineer. I also operate drones and rovers, and when we had time, we need to support others members' research projects. So for the small rover, it was shipped directly to Hawaii, and then I assembled it there. Of course, we had some difficulties on the way, but the rover was remotely operated by a remote port in the Netherlands while we were in Hawaii on the mission. So that was really nice. The drone itself has been around with us for some time now, and he has provided some amazing footage from the mission, but also is very helpful when you're doing surveillance of the area and when you're trying to find lava tubes around the habitat. It was quite useful. Other engineering tasks mainly comes from troubleshooting, and you have to be creative in the matter. We are using toilet paper to try to find the leak. And that also we needed to do some EVAs just for troubleshooting. It was very hard, but also quite fun.
So as part of the task of being a crew physicist for the team, I did mostly some research about food development on the moon or on Mars. And we're really interested in how to develop a greenhouse system that can use in situ materials, such as the soils that are present on the moon or on Mars, and use it to grow crops on. So we were collaborating with Food for Mars and Moon and Wiegenwabeling for this research. And another part of the research was to see how the radiation environment, for example, on the moon or on Mars, which is quite higher than here on Earth due to the lack of an atmosphere and low magnetic fields, how this would influence the crops itself. Like what kind of mutation would come forward, or what would you observe, or is there enough contamination that you need to protect the crops from? So this was quite interesting to test. Another thing is that we use different percentages of compost to add to the soils to see how the crops grow, and that we need to bring less material from Earth to reduce the payload for the rockets that also can be used for medicine or other important materials that we need to bring to Mars. So it's very important to look at what you have on those other celestial bodies and to see how you can use that to set up your base over there. Another important research that we did was the diet and nutrition of astronauts. So what kind of influence does a different diet have, or different nutrition values have on the astronaut and how it performs during the day? And this research was conducted with Joanna Chapuis, a dietist from France, which was quite an honor to work with her. And we made like a dietary plan with the dry freeze food that we had available at high seas. So we got like different meals during the day with enough nutrition so that the astronauts could perform correctly. But another important factor that we came as a conclusion of this research is that cooking those dry freeze materials, actually, like cooking the materials and establishing like a nice dinner meal for your crew and eating together as a social gathering moment during the day is really important for your crew bonding. So this was a nice observation, and I think it's really important to see how important it is for the astronauts to have that social aspects to stay mental stable, actually, especially in space.
Yeah.
So another part was the lava tube exploration, of course, because lava tube exploration is very important when you go to the moon or Mars, because there are lava tubes present there. And these lava tubes can be used for protection against radiation or meteorites, or can offer some already some boundaries where you can place a habitat in. So especially in the early moments of developing a habitat, it would be really important to see if we can stay inside a habitat and construct a habitat inside a lava tube, actually. Another important thing is the geology of lava tubes, how they are formed and how they are present on the moon and on Mars and on Earth, and what the differences are between them. But also life. Life can actually be present in lava tubes on the moon and on Mars because it is protected from the harsh space environment, actually. So for this mission, we conducted multiple EVAs inside some lava tubes that were nearby the habitat, which were around 30 minutes to 2-hour walks. So on the left, you can see the team actually exploring, making our way over the lava flow itself, to find a lava tube, which were quite difficult to find. So drone, where Anne was talking about, could be really useful. And another not so cool EVA, which was pretty important, was dropping our garbage, such as the poo and the pee, to another facility. So this was also conducted during an EVA. And our commander Michaela Wisilova, she was amazing with this. She helped and assisted so much with this difficult task. So total respect for her.
All right, and another important research that was also conducting during our mission was about space architecture and 3D printing. Unfortunately, Sabrina and Ariane cannot be here to explain better. But basically, we teamed up with the 3D company MakerBot, and they provided us some amazing 3D printers. And that way we can use additive manufacturing during our missions. And that is very useful because as an astronaut, when you're actually going to space, to Moon and Mars, you have limited amount of space and of course a storage and also the weight that you can bring. So you cannot bring all the tools you need, but if you have a 3D printer, you can actually just print these on the moon. And even more exciting, you can use insider resources, you can use the materials available there to print this for you. In this case, we use the normal printing plastic, and we use that as for some tools for our equipment, but also you can use that for leisure and as personal equipment. I mean, like sometimes you want a souvenir from your family or something that reminds you from Earth. And if you cannot bring in, you can also use the 3D printer for that. And our mission, it was near Christmas, so use that to print some Christmas decorations, some cookie cutters, and also some Christmas trees, as you can see here. And that really added up to the overall value of our mood, and also to bring the crew together as a team. Another important study they conducted was a semi-private room, because besides from your sleeping quarters, everything else, of course, in the toilets, everything else is shared on the habitat. But then Sabrina and Ariane, they created this semi-private room where you could chill out during the day, just if you needed some 5 minutes alone from the crew or just to rest a bit, to clear thoughts. That was very helpful. And another experiment they conducted was about the color study on the habitat. And the first week, the whole habitat was covered in white, and we were not allowed to wear any colors. So for a whole week, everyone was kind of grumpy, as you can see in the picture. But then on the second week, they brought the colors back, and that also helped improve the mood a lot. Of course, we used the Christmas decoration to brighten up the mood and everything. And they perform everyday psychological surveys that we had to answer every day. It was kind of exhausting, but then they found out there was an overall improvement of everyone's mood when the colors were introduced back to the habitat. And there's an important part of space exploration that sometimes we forget to talk about. And about the challenges and outcomes of the mission, of course, when we're very busy, we have so much going on, and with troubleshooting and everything, is a very demanding daily schedule. So we try to follow the daily schedule of 24 hours. We try to sleep at least 8 hours so everyone is healthy. But of course, we also have our daily chores, we have projects, we have other tasks, and we also need to exercise for an hour a day, and that makes the days go by so fast. This is a challenge. Another thing is the distance and isolation. For troubleshooting, for limited communication windows, we only had a few hours a day to talk to mission control and remote support. And if you have any urgent matters to address, that can be quite challenging, because first you need to figure out for yourself, because help is days away from you. So that's one of the challenges. And for outcomes from the mission, we provide some feedback and improvements from the equipment and the habitat itself, as you can see here, some examples. And also we try to create protocols for further missions, so their missions can be They can focus on their own areas of research, but we can also create protocols for space exploration, and for eventually when we colonize Moon or Mars, we have some idea what's important and what's not. And that's it. Thank you. If you have any questions, you can reach out to us and be happy to answer them. And also, of course, we need to thank our sponsors. We are here below. They made this mission possible, and without them, we wouldn't be able to go to the moon for 2 years. So thank you.
Thank you, everybody. Have a good day.
Ciao.
Okay, so thank you guys. This was the presentation from me and Anna. Mark, back to you.
Thank you very much. I think that was a wonderful presentation, and I think it also presents a nice overview of all kinds of research that can be done and that still needs to be done before we can actually start our lunar or eventually Martian settlements. And speaking about building lunar or Martian settlements, I would like to introduce our last speaker of the day to you. Sue Fairburn from Canada is calling in. Hi, Sue. Great to have you.
Hello, Mark. Nice to see you too.
We have met Sue via Suzanne Christianen. Last time we were in Iceland with Chill Ice, and she will help us design and build the prototype habitat for inside the lava tube. And she will now tell a little bit more about the projects that she has been doing.
So I just pulled together a few slides, and thank you very much for inviting me to join you. I've only heard the last sort of hour, 45 minutes, so I really look forward to being able to share with my students, I think, the whole collection of perspectives that you've shared today. I was particularly interested in Space Iceland's presentation, and I only caught the last part of it, but I really look forward to finding out a lot more about their plans and what a phenomenal job they're doing on limited resources. And thank you very much to the team. We've just met the once, I guess it was last in October, I believe, and talked about how we might be able to work together. So I'm just going to talk you through a little bit about our program, a little about the projects we've done so far, and if you have any questions, I'm happy to answer them. So I've titled this Prototyping Design for Extreme Users and Environments. And I think this is actually an image from a series right now on the Knowledge Network in Canada, and it is has been developed by Search and Rescue on the North Shore of Vancouver. And they're doing a fantastic job capturing the extreme challenges, the unique nature of the service that they offer, and how equipment and apparel and how that equipment and apparel becomes life-saving for them. So some of the slides that I taught to you'll see reference this. So I'm presenting from Vancouver, and Vancouver is quite unique in that we are a temperate rainforest. For anybody who's been here, it's quite an urban environment nestled in these amazing surroundings of water and mountains and forest. If you're standing downtown and looking to the north, this is the view you see up to the mountains. If you're standing on those mountains and looking south, this is the view you see to Vancouver. So we have this area here called Stanley Park. It is a beautiful, this whole area would have been inhabited by the Indigenous peoples, so the First Nations. And they're so rich in culture, and they've taken such good care that we are now learning from them how to continue that forward. Our school itself is actually based on this flat area down here, which is where the airport is, around there. So Wilson School of Design, which is part of Kwantlen Polytechnic University, is about 40 kilometers from this area, these North Shore Mountains. But we're very close to the sea, and we're very close to the Fraser River, which is also a place of great industry and recreation and really important ecological area. So as you can see, we're set in this spot where we have endless opportunities, but also endless challenges. We are locked by water here, and we're locked by mountains there. So it tends to be quite a dense area. I'm presenting to you this morning from this area up here, which is up on Bowen Island. So I live on a little island that's just about a 20-minute ferry ride from the northern part of Vancouver. Our program itself is interesting. It's a product design program that started about 8 years ago. So we're still really in our infancy. So we're taking on big challenges and I think learning as we go, but it's been quite a fantastic opportunity. I only joined the program coming on 3 years ago. I'd previously been working in Scotland the last 10 to 12 years. The program sits within product design, and the way that we've set it up is that first year is a typical program with fundamentals, foundation, discovery. The students then move into exploration, divergence. This third year is where I'll be talking about, because that's where we start to get into engagement and practice. And that's the time that the project that we'll be doing with the Chill Ice group will be nestled into the second term of their third year. It's a really important term for the students. It's a really important year for the students, and it leads them into their final or their honors year. The project will be sitting within what we call design implementation. It's their 5th studio experience. We've set it up so that there's 2 projects the students do. One is team-based, and one is an individual personal protection or personal protective equipment project, which last year obviously took an interesting turn with COVID becoming very serious just at the point when we began that project. So the students obviously had a really good grounding and a really good first-hand set of experiences about the importance of personal protective equipment. This coming term, we'll be keeping the same structure, so there'll be one team project, and that team project, we're looking forward to working with the Chill Ice group. It'll be online and in studio, so it'll be hybrid, which will mean we'll have limited access to our studio facilities, which I'll talk you through right now. So I've spoken about the type of projects we tend to take on, and they tend to be in high-risk environments and have some of these unpredictable problems for which we need to consider all eventualities. This is an image from the project we did last year, which started to reflect on the fact that Everest is being overly accessed by a lot of unprepared people, and the result of that has been an increase in the amount of altitude mountain sickness. So our students do, as any design students, they define the problem. Here's the example from last year, looking at both climate change, this mountain madness factor, inaccessible innovation in these high-risk environments, and leading to overall these increased dangers. So the result is that we really look at the students trying to identify those problems and then to really move into prototyping quickly so that they can prototype fast and fail fast. It's a highly iterative process. It's highly hands-on, so they'll be doing material testing probably from the 2nd or 3rd week. They then definitely look at the body extensively, and they also look at a lot of regulations in regards to specifications for emergency equipment, medical equipment, etc. So a lot of the ISO standards. One of the aspects that we stress to the students is the importance of accessing expertise. So we, in fact, identify some of the experts and arrange for them to meet or speak with the students. Last year, this included a couple of recent individuals who recently completed the 7 summits, including Mount Everest. So a local female climber, Elizabeth Rose, and Captain Chris Dare. We also expose them and introduce them to medical experts. In this case, it's Dr. Stephen Roy, who is high altitude medicine expert, and Dr. Chalal, who's the president of the Canadian Society. And then lastly, we talk about expertise in also the body with a baromedical specialist or hyperbaric medicine specialist, and then design and technology. And so that's where we have access to some fantastic industry partners that we work with. Must Mustang survival is probably the one that we work closest with, and Wendell Euglin has been a big part of our program from the very start. So Wendell always joins us and brings his both his experience and his hands-on construction. And then last year we started working with Maxime de Jong, who is with Thin Red Line Aerospace and is actually working on moon habitats as well. So we've reached out and we've had an amazing response. I'll just cover these slides briefly, but we go through the process with the students. And I think the main thing to stress about this project is it tends to only be a 7-week project. So the students are moving in an intense way. We're throwing a lot of information with them. They're having to prioritize which aspects of that information is most important. They're also having to identify where there's gaps in their knowledge and to identify which experts they need to access to fill those gaps. They then very quickly move into, like I said, material testing, both in a soft product environment and in a traditional hard product workshop environment. One of the aspects that I've mentioned that becomes so essential is the field testing of prototypes. So because we're in this temperate rainforest, we have access to a whole range of different environments, from on the water to in the mountain to snow. And we look at how the students can take their early full-scale constructions into the field and identify how best to challenge the materials, the construction, the form, and the functionality in the very early stages. So this is Horseshoe Bay, which is just on the northern part of Vancouver, and this was a project the first year I joined KPU where the student team designed what's called a burrito, which is a passive thermal rewarming device. And then this is an example of the project from last year, which is the one I'm about to show you, Alta, which is a personal hyperbaric chamber. Excuse me. And this introduced a whole other realm of problems and possibilities for the students. For 3 years, they'd focused on thermal aspects, so multi-layer construction, up to 7 or 8 layers often, with this polar burrito right here. And last year they went to an inflatable, which obviously required significant refinement and precision in construction in order to be airtight. This was the end result, was the Alta hyperbaric chamber, a single person, very lightweight, drastic reduction in the weight because the students also redesigned the pump so that and the carrying case, so that could further reduce the weight and mean that this was essentially an introduction into this very niche market that brought with it a lot of benefits, and more people could have it with them. Excuse me. So the most recent project was the inflatable project, which is clearly of relevance as we move forward the 3 prior years. And in each case, we look at different contexts. In 2017, they worked with North Shore Search and Rescue and looking at peri-urban area recreational users. Excuse me. In 2018, we worked with a group that are polar snorkelers, a female group of polar snorkelers who go on expeditions. And we designed the polar burrito, which was obviously designed for much colder environments, very specific ground activity, use in a zodiac, use on a vessel. And then in 2019, we designed for marine use, specifically in the urban area, and that was with the Canadian Coast Guard. And these are the 3 final prototypes that you see here for the thermal bag, the burrito. I'll leave it at that and just say that if you'd like to see more information or find out more about the program and the facilities and the students, this first video is about the polar burrito, but it has some fantastic footage of the students in their development, their construction, their material testing, and their on-site testing. And that project actually won a Core 77 award, both Commercial Equipment Award and a Community Award. These are my contact details, and just to say that we are very excited about joining the group in 2021. And I know there will be some challenges in terms of working remotely and time zones and everything, but they're not challenges that the students will likely be daunted by. So if you have any questions, happy to answer them now.
Good. Excellent. Yes, I have a question, Sue. I'm Bernard Fang from ESA and EarthMoonMars. About the timeline, so you mentioned 7 weeks, so that's from January on. So is there some also preparation now in terms of literature, getting also some of the work defined? Because there will be quite a tight schedule also for production, for testing. So are they able already to impregnate themselves with the issues?
Thank you very much, Bernard. Unfortunately, there's not too much preparatory time. We've found that the students essentially appreciate that it's a very immersive experience, and we just throw them right into it. We have shared the links with the students. They're just finishing off their fall term right now. I'm more than happy to share more links with them over Christmas, but we have found that we find that the first 2 to 3 weeks, they really get up to speed fast. One of the other things is that we may be able to extend it to 8 weeks. And what we did in the case of the Polar Burrito for the second year, because it actually ended up going on an Arctic mission, we did some further refinements to it after the term. Yeah. So the project itself sits in that term. They end up with a fully functioning prototype, hopefully. This is a larger scale than we've worked before. However, it's also a single construction or a single layer potentially, or fewer layers, which eases some of the construction. So the students should be able to do some of the construction both at the school and remotely.
Okay. And so after the 7 weeks, so you have also some margins to validate, the deployment, the transport, also the safety, because it will be used with humans. So how do you see the period of testing and review of that?
The testing, they do some of it. So in this case, we'll have to look at what the specifications require, and they'll have to essentially develop those in combination with the Chilice team. But I think for the most part, that will happen on site during the project. Like I said, there'll be some further follow-up. Safety, we have to look at what the factor of safety is for this. And I think because it's in a lava tube, some aspects of that are going to be a little bit challenging for us to do from here. So some of that proof of concept will unfortunately have to happen on site in May or June.
Yeah, and you are considering to have a few team members that would join the campaign. So what is your view on that?
Yeah, I think our hope would be that that's a possibility. I've also been in contact with Susan Christianin about a workshop that has invited me to co-host. So my hope would be that myself and at least one and possibly 2 others. So so that if there's further revisions needed or any further support needed, we're there. It would be fantastic if one of the students could also join.
Yeah. Okay, thank you.
That would be really great to do. Thank you. Okay, Mark, I think the word is back to you.
Yes, okay. Thank you so much, Sue. I think we now have some time left to have an open discussion with all our members that are present here. I have some new members. I think, yes, Kyungwan, Kim, I'm very glad to see that you are still here. Hello. Can you maybe give a brief introduction to our viewers who may or may not be familiar yet with your work?
Yeah, thank you for inviting me, Bernard. And good to see you, Mark and Anna and Sabrina. So yeah, it has been about 3 years, I think, to join, or 2 years probably, to join the EarthMoonMars and ISTEC. I have presented only one time about my master project 2 years ago, and right now I'm architect. I live in Paris as an architect and space architect, and recently it was very interesting presentation, by the way, because recently me and our lab member just started to participate in NASA competition of break lunar ice competition. So we are just making a team. So it's a very interesting presentation of you guys. And then if there's someone who is good of engineering or system architecture, it would be our pleasure to work together, probably. Thank you.
Okay, great. Well, very nice to hear from you. Bernard, did you maybe have some open questions for, I think we have 16 participants now also in our Zoom, so we can have a sort of open panel discussion maybe.
Yeah, that's good. So one point I would like to bring that there's also a partner, which is IPSA Toulouse and Paris. And unfortunately, so Rokana was not available, and for some reason, okay, nobody was felt invited to present something specifically, but they have done since already 3 months some work preparation in support for the campaign. In particular, they have done some space habitat studies. They have also looked at subsystems that they could contribute, and for instance, they looked at the energy system recently. That's something that they could help with. And they are also interested to provide some backup astronauts that could be also maybe shadowing some of the astronauts that have been already selected. So there's another group as well, TU Dublin, and we will have 4 of them that will come to the Netherlands from February. So they will have some training in MPOL, in the Poland campaign, and possibly also they could contribute to some support studies for Chile ice. And so there will be one which will be specialized in telescopes, one will be specialized in instrument for astrobiology, and there will be also one which will be in astronaut operation. So we could also count on them. And we looked at in synergy with the other EarthMoonMars program, we should establish a kind of also a test bench facilities. And I believe that the Netherlands could be a good place to do part of the work in complement to what is done in Vancouver, but for some of the equipment that we would put inside. So also we will look at using some hands-on the technical bench and workshop that we could organize here in the Netherlands, because we have many members here, and possibly also testing some element in some previous campaign in the European continent before we merge this big subsystem in Iceland. So that's how I see that we are looking very much forward having some use of the heritage from our campaign, from EMIS, also from MPOL. Also, we are something we would like to discuss with Sue is the system that is being developed at some stage. We are interested to look at the blueprint where eventually we could have, one of each on each continent, and then we would continue to use some of the system. And so not only the challenge of deploying an habitat or laboratory, but also making it operational for a laboratory. So we are looking at something that could be also sustained for a follow-up step.
Yes, I think that would be a very nice idea to have an international or actually intercontinental collaboration and see how we can start to establish a network between several analog environments, because we will need to look all over the Earth to simulate all over the Moon and Mars or the rest of our solar system.
Yeah, but of course, I mean, it's also a practical aspect. If you want to do some technical change, okay, it's good to work close to a technical place. So like, Vancouver University that Sue has mentioned, like also our cluster of EarthMoonMars collaborators in Europe. So all the technical preparation work is good to have it localized. And then we use this extreme field campaign really to test in a extreme environment. But then after you can come back and make the next iteration for the next challenge. So it has also, it can be localized in some nodes from our worldwide cluster. And I believe that yeah, it's a good way also to share the workload efficiently.
That's a great plan, Bernard. Thank you. Yeah, so I think we covered most of it, and we have like 5 minutes left for this meeting. I think, Mark, we would like to thank everybody that came today and presented their work. If you have any questions, or if you want to get to know more about Chilice mission, you can email us to info@chilice.com. I also set the email in the YouTube link. So yeah, feel free to email there, and we will add you to the newsletter. You will get monthly updates about the mission itself, and if you would like to contribute your research, your projects, your equipment, or if as a company you would be interested to support this mission, feel free to let us know. And I think we would like to thank all our contributors today for their awesome presentations. Thank you.
Yes, and also many thanks to some of our partners who could not be here today, but are still with us, of course, in the project and the successful collaboration that is Chilice. Okay.
Before we all separate, we still need to do a Chilice family portrait with all of you on the camera, so that we will also show the extent of our collaboration. And also, it's important that we distribute a kind of fact sheets of what is the scenario. So for the number of person, on-site, a bit off-site support, to have an idea of the scale of the different roles that will be played on the side, but also remotely. And we have to give a task to everybody. Yes.
Yes. Okay, if everybody can put their screen on.
Yes.
We can make a picture or a screenshot.
Exactly. Yes. So let's do that.
Okay. Bernard.
So everybody, yes. How many are we? Okay. So these are the survivors of the which was this Earth, Moon, Mars, and Space workshop we started yesterday. And I think that, yeah, it was quite amazing that we had a contribution from a number of continents that we had yesterday, also even Africa and Asia represented. We have North America. We have also Korea and okay, 2 continents are missing. Nobody from Antarctica and nobody from the moon, because of the 8 continents. So this is something we are targeting for the future, and through a mission like the Chilice one and also the other one, we are preparing for, yes, future events where a few of us will be also on the moon. Now, before that, we will bring some robotic payload. We will have the moon gallery, we'll have some Zebra rover, we'll have also some of our artifacts. So we will also partly be on the surface of the moon in a few years. But clearly, I think that, okay, I really appreciated also the way you have organized this day-to-day, the EarthMoonMars team, the Moon Gallery as well. So that's a great presentation. So it was all captured on YouTube. And we are going to share it with the world. Eventually, I have to make some little edit, but I believe for a real-time Moon Mars TV, you have done a great show today. So thanks very much to everybody.
Yes, thank you too, Bernard. Okay. Then I will stop the live stream now.